Hello everyone. So in this lecture, we'll see what is power factor and why this power factor is matter in daily life. So what is power factor? So in the definition, we can say this is the ratio of real power, which does some useful work to that apparent power. So we can write that power factor is equal to real power, real power. So that is in kilowatt and apparent power. So it is denoted by kVA. So what is real power? What is real power? So simply we can say that power that does actual work. So power that does actual work is called real power. Like running a fan. So means when by using this power we are running a fan. So it is giving it is doing some useful work like bulb. When this bulb is glowing, it is giving the light. So it is doing some useful work like motor. When the motor is running, so it is doing some useful work. So this type of power is called real power. Now we'll see what is reactive power. So there is another power, it's called reactive power. So this is denoted by kvar. So there, that we can say that wasted power due to that magnetizing effect in inductor and motor. So this is the wasted power. So in due to the magnetizing effect in inductor and motors. Now what is apparent power? What is apparent power? Apparent power. This is kVA. So this is the combination of both, means total supplied power. So this is real power plus reactive power. Reactive power. Real power plus reactive power. Now, if the power factor is 1 or unity, if power factor is equal to 1 or unity means all supplied power is used usefully. So this is the ideal case. So this is called ideal case. Now, if power factor is less than 1, so means some power is wasted in the form of reactive power. So some power wasted in the form of reactive power. Okay, now we'll see why this power factor matters in daily life. Why this power factor matters in our daily life, like electricity bills. So if we consider that electricity bills. So like utilities charges extra if power factor is low. If power factor is low, so in that case, whatever we are using like light fans, then it will charges extra. So because of more current flow and increased system losses. So when the power factor is less, current flow will increase. That current flow will increase. Current flow will increase. So if current flow is increased, then it will losses will increase. Losses will increase. Losses will increase. So this is the effect of low power factor. Like in industry, with poor power factor, get penalties from the electricity department. So because of low power factor, now like how it is affecting. Second one is that efficiency, efficiency. So if we talk about it, that efficiency, if low power factor, so because of that low power factor, more current will be there, more current consumption will be there, more current consumption. So when there is a more current consumption, so that is I square R loss will increase. If I square R loss will increase, then more heating, then there will be more heating. So if there is a more heating, then less efficiency, less efficiency. So this is the effect of low power factor. Third is appliance life. So motor, fans and AC with low power factor run hotter. So that motor, fans, AC with low power factor with low power factor run hotter. That means wear out faster. So they are wear out faster. So fourth is infrastructure cost. So how this low power factor affect on cost? So for the same useful power, if power factor is low means thicker wire. So bigger transformer means higher cost. So that's why this power factor matters in our daily life. We have used fan, fridge, all are inductive load, and their power factor always less than 1. Then tube lights with the old chalk type had low power factor, so that capacitor bank is used to improve the power factor. In industries also, for the power factor correction, that capacitor and synchronous condenser are installed. In industries they used capacitors and synchronous condensers. So for improve the power factor. So from simple analogy we'll understand this power factor. So think of power factor like drinking soda with foam. So the liquid is the real power. So here liquid is real power. Means useful. Then foam is reactive power. So that is wastage. Now the glass is full of liquid plus foam. So that is apparent power. So higher foam means low power factor. If higher foam means low power factor means less useful soda for the same glass size. That is less useful soda for same glass size. Same size. So this is the simple explanation of power factor and effect of power factor in our daily life. Okay, thank you everyone.